Hey guys, so welcome to this video, and this will be a pretty quick video where we just quickly discuss uh, some of the exponential and logarithmic formulas that you'll use this semester. So we've actually already worked with some of these functions this semester already. So some of these should seem a little familiar to you. Exponential functions generally have this look to them, this y equals a b to the x plus c. What's really important to just take notice is your variable is always going to be in that exponent position, okay? And that's how you know you're dealing with an exponential function, all right, when that variable is in the exponent position. Now, if you have logarithmic functions, in this class, we're mostly going to work with the base 10 log and the natural log. And here are a couple of examples. And like I said, we've already used these a little bit in our formulas that we've dealt with already and early in the semester. So let me show you a few examples here of how this all works, okay? So let's say you have this exponential equation, y equals e to the x plus 6. And they're saying, what is the value of the equation when x equals 2? Okay, so in Excel, you're just going to put your 2 in for your x, and then your formula will look like this. All right, and then you'll hit enter, and you'll get a value. And if I did everything correctly, I think this comes out to be 13.3891. And so, like I said, we've already done some of this stuff already. If we have a situation where they're wanting you to find X when you're given a value, so like let's say the value is 527.13, okay? Essentially what you're doing is solving this equation. So let me write this out because sometimes this is helpful to think about. Okay, we're going to solve this equation right here. Find that x value that makes that true. Now, if we were to solve this algebraically, we would have to use our natural log function. Okay, and you have probably done that in a previous class, but we're just going to use our goal seek. And so what you're going to do, the formula is in that cell there, and you're just going to drop that 527.13 in the box, and then you're going to do your goal seek to solve for that t value. And I would like for you to pause the video and actually give that a try to see if you're getting the correct number. All right, and like I said, if I've done everything correctly, it's 6.256. All right, and that would be your, sorry, I don't know why I wrote a t there. That should be an x, okay? And that would be your value for x, all right? So it's a lot easier than using our natural logs, a lot quicker, all right? All right, so compound interest, hopefully you've seen this formula before, and we're going to use this several times during the semester. Your P is your principal, your R is your rate, N is your number of times you're going to apply that interest per year, and T is the number of years that have elapsed. Make sure with your interest rate, you change that to the decimal before you put it into the formula. All right, so let's do a quick example here. It says if you invest $2,000 compounded monthly, so let's set our formula up. So $2,000, that's your principal, and then it's going to be 1 plus, okay, our rate is 2.5%. As a decimal, that'll be 0.25. Compounded monthly, so that's 12 times a year, and then to the 12t. So that would be the function if you just have to set that up. And then what they're wanting you to figure out is what will you have in 2 years. So they're wanting you to find A of 2. All right, so you're going to put a 2 in your cell here, and then your formula is going to look like this. So you'll have 2,000 times parentheses 1 plus 0.025 divided by 12. I ran out of space over here, so I'm just going to carry it down below. But obviously you keep that all in the same formula, and it'll be 12 times your cell reference for your t value. And make sure you put the parentheses around this exponent here. That's the part that a lot of students leave out, or those parentheses, and that will create an issue with getting the correct value. All right, so that should be, let's see here, when you put that all in, you get $2,102.43. So try to put that in and see if you're getting that same answer. All right, so then here it says, how long will it take for your investment to have a total value of 5,000? Okay, so we're going to actually solve this equation using Excel. All right, we're setting that equal to 5,000. If we were to solve this by hand, we would have to use our logarithms, okay? And so with Excel, all we have to do is do our goal seek. All right, so we're going to drop 5,000 in that box there where we have that formula. And then we're going to do our goal seek process. And you should get T equals 36.6898, I believe. And this would be years. Make sure you put a unit in your answer, okay? That's a long time for your money to get from 2,000 to 5,000, but you've got to realize this is a really low interest rate, okay? 2.5% is pretty low. And also you're just dropping the money in the account and you're not adding any money to the account. And so it's just sitting there, you know, so you're not doing anything to try to increase that investment. I'll talk a little bit more about that here later in the video. All right, so here's our continuous interest formula. A lot of students like to remember PERT. Okay, that helps you remember it. PE to the RT. P is principal, R is your interest rate, and T is time, and you have that base of an E in your exponential function. So it says, hey, if you invest 10,000 compounded continuously at a rate of 3.8%, what would be your total investment in 20 years? So let's just write the function. So our principal is 10,000, base E, and our R would be 0.038, okay, and then T is your variable. So in 20 years, we're looking for A of 20. So what is that? So we would drop 20 in our value for T, and our formula will look like this. So it'd be 10,000 times EXP parentheses 0.038 times cell reference where you have that T value there. Once again, be careful with these parentheses, right? Make sure that you've got the correct stuff inside the parentheses representing, right? You're representing this whole exponent, okay? That's in off of that base E. All right, so let's see, what do you get there? I believe you would get 21,382.80, and that would be dollars. So that's what you would have in there in 20 years, okay? And then if we, the second part says, how long will it take your investment to have a total value of $12,000? So in that case, what you're going to do, right, is drop that 12,000 in that box where you have that formula, and you're going to goal seek, and you'll find your T value. So 4.7979, and that will be years. Okay, once again, that's a lot faster, right, than us solving it by hand. Okay, so just kind of a note about investments in general. I like to share this with students because you guys are young and you've got your whole life ahead of you, right? And you can really do some powerful investments because the younger you invest, the more powerful your money will be. So like if you, I want you to spend some time Googling Roth IRA, and I want you to study up on that. Generally, Roth IRAs have a 6% in general investment rate. And it does vary depending on the market. Okay, so that's just sort of an estimate. And what happens is you put your money into these Roths right now as you're earning it. You pay your taxes. Okay, you pay taxes on this money. Okay, and then you're dropping some money into your Roth. Okay, so what happens? Like, let's say you start with, say, like $5,000, and then let's say you get a job, and let's say you can spare $500 per month. Okay, so be frugal with your money and save. And then you drop this $500 into your account each month. All right, and then it's just going to compound. The interest is just going to compound. Okay, and there'll be spurts where your interest is actually higher than 6, and then sometimes lower than 6. Like I said, the investment rate does vary depending on the market. All right. Um, but let's say you let that sit there for, like, you keep doing that for, let's say, 25 years or so. Okay, what you're going to have, and like I said, this is just an estimate, but you're going to have like 1,000,000, like $500,000 in that account. Okay, if you keep doing that for about 25 years. So when you're like, let's say you're 22 years old. Whoops, that's not a dollar sign. Let's say you're 22 years old right now. Okay, and then 25 years from now, let's say, you just keep working and you keep steady doing this, then you're a 47-year-old person, and you've got this much in that account. So you're already a millionaire. Okay. And a lot of people actually, will retire around 60 years old, 65 years old. So of course, that's just going to make that even bigger. Okay, when you're ready to retire, right? So then you can retire, and you have all this money that you can, spend, or just have, for just traveling or whatever you want to do once you retire. Okay, so hey, look into that. Okay, because this is what me and my husband did, is when we got out of college and we were 22 years old. Okay, I don't know why I keep putting a dollar sign on that. So we were 22 years old. We started investing our money. Okay, and now we're ready to retire. Okay, so we're both in our 50s, like, okay, and we're going to retire. All right, so hey, this works. I can vouch for it. All right, invest when you're young. Let that money grow and build, and you'll be so, so, so happy 25, 30 years down the road that you did that. All right, so anyway, thanks for listening. That's just my little life advice for you. All right, if you want to talk more about it, let me know. I love talking about that stuff. So anyway, you guys have a great day, and I'll see you in the next video.